6841. What constitutes the payload of a balloon? A. Total gross weight. B. Total weight of passengers, cargo, and baggage. C. Difference between empty weight and maximum certified gross weight. The correct answer is B. The payload of a balloon refers to the total weight of passengers, cargo, and baggage carried on board. It includes the combined weight of all individuals on the balloon, any items or equipment being transported, as well as any personal belongings. The payload is an important consideration for balloon operations as it directly impacts the performance and capabilities of the balloon. Factors such as lift capacity, rate of climb, and fuel consumption are affected by the weight of the payload. In this context, the payload is specifically defined as the total weight of passengers, cargo, and baggage. This excludes the weight of the balloon itself or any other factors unrelated to the items being carried. Therefore, the correct answer is that the payload of a balloon consists of the total weight of passengers, cargo, and baggage on board. 6804. The center of gravity of an aircraft is computed along the A. Lateral axis. B. Vertical axis. C. Longitudinal axis. The correct answer is C. The center of gravity of an aircraft is computed along the longitudinal axis. The longitudinal axis of an aircraft is an imaginary line that extends from the nose to the tail, passing through the center of gravity. This axis divides the aircraft into two equal halves, with the left side and right side being symmetrical. Computing the center of gravity involves determining the location along the longitudinal axis where the total weight of the aircraft can be considered to be concentrated. This calculation takes into account the weights and positions of various components, including the fuselage, wings, engines, fuel, payload, and any other equipment on board. By accurately determining the center of gravity, pilots and aircraft designers can ensure that the aircraft is properly balanced and stable during flight. It is crucial to operate an aircraft within its prescribed center of gravity limits to maintain safe and predictable handling characteristics. 6805. The center of gravity of an aircraft can be determined by A. Dividing total arm by total moment. B. Dividing total moment by total weight. C. Multiplying total arm by total weight. The correct answer is B. The center of gravity of an aircraft can be determined by dividing the total moment by the total weight. The moment of an object is the product of its weight and its distance from a reference point or axis. In the case of an aircraft, the reference point is usually a designated datum. To calculate the center of gravity, various weights and their corresponding moments are measured or obtained for different components of the aircraft, such as the fuselage, wings, engines, fuel, payload, and other equipment. The moment for each component is calculated by multiplying its weight by its distance from the reference point. Once the individual moments are calculated, they are added together to obtain the total moment of the aircraft. Similarly, the total weight of the aircraft is determined by adding up the weights of all the components. Finally, the center of gravity is determined by dividing the total moment by the total weight. This calculation provides a specific location along the longitudinal axis where the aircraft's center of gravity is positioned. It is important to note that maintaining the aircraft within the prescribed center of gravity limits is essential for safe and stable flight. Any significant changes in the distribution of weight can affect the aircraft's balance and handling characteristics, potentially leading to instability or control issues. 7309. With respect to using the weight information given in a typical aircraft owner's manual for computing gross weight, it is important to know that if items have been installed in the aircraft in addition to the original equipment, the A. Allowable useful load is decreased. B. Allowable useful load remains unchanged. C. Maximum allowable gross weight is increased. The correct answer is A. When additional items are installed in an aircraft in addition to the original equipment, it is important to consider their weight and its impact on the overall weight of the aircraft. The weight information provided in a typical aircraft owner's manual is based on the original equipment and configurations specified by the manufacturer. If items have been added to the aircraft, they contribute to the total weight of the aircraft. This means that the overall weight of the aircraft increases due to the additional items. As a result, the allowable useful load, which is the maximum weight of occupants, baggage, and fuel that can be carried by the aircraft, is decreased. The original equipment and configurations are carefully considered during the certification process, and the maximum allowable gross weight of the aircraft is determined based on those specifications. Any additions or modifications that increase the weight beyond the original design parameters can exceed the maximum allowable gross weight, which may compromise the aircraft's structural integrity and performance. Therefore, it is important to account for the weight of additional items installed in the aircraft to ensure that the aircraft remains within the allowable useful load limits and does not exceed the maximum allowable gross weight. This helps maintain the aircraft's safety and performance capabilities. 6802. If the nose wheel of an airplane moves aft during gear retraction, how would this aft movement affect the CG location of that airplane? It would A. Cause the CG location to move aft. B. Have no effect on the CG location. C. Cause the CG location to move forward. The correct answer is A. When the nose wheel of an airplane moves aft during gear retraction, it means that the weight distribution of the aircraft is shifting towards the rear. This shifting of weight towards the tail of the aircraft affects the location of the center of gravity, CG. The center of gravity is the point at which the total weight of the aircraft is considered to be concentrated. It is an important parameter that influences the stability and control of the aircraft. The CG location is typically specified by the aircraft manufacturer and must fall within certain limits for safe and efficient flight. When the nose wheel moves aft during gear retraction, it indicates that the weight previously supported by the nose gear is being transferred to the main landing gear, which are typically located closer to the aircraft's center line. This redistribution of weight towards the rear of the aircraft causes the CG location to move aft. As the CG moves aft, it has implications for the aircraft's stability and control characteristics. Generally, an aircraft with a more aft CG location tends to be less stable, as it becomes more sensitive to pitch changes and has a reduced ability to recover from stalls or other disturbances. It may also affect the aircraft's maneuverability and control response. Therefore, in the given scenario, the aft movement of the nose wheel during gear retraction would cause the CG location of the airplane to move aft as well.